The database is golden. This is really all I should need to say, right? The database contains information about your customers, data that they care about. If you're testing your app on that, you're going to die a horrible, horrible death. So the Rails solution to this common problem is that it actually provides 3 completely separate environments. And each environment has not only its own database, but also a collection of behaviors that can be changed to be the appropriate thing for the environment. We'll see more examples of this today. The 3 environments are called development, which is where you do your coding and testing, production, which is the real app out in the world, and the test environment, which isn't really an environment for you at all. It's an environment for the testing tools. We're going to start talking about those tools next week, and you'll see that the testing tools have a tremendous amount of automation around how tests are run, and they sort of own and control the test environment. You never really deal with it manually. So the question is, if this is true, how do you make changes to the database? Because if there's different ones for development and production, whatever you do in development, you'll eventually also have to do those same changes on the production database. And the solution in Rails, as well as in some other systems, is called a migration, which is really just a script describing how you're going to change the database. And the idea is that even if the database is of a different type, for example, we're using SQLite for development, but when you deploy stuff on Heroku for Homework 2, Heroku uses Postgres, totally different system. But the scripts are written in such a way that they're source portable across different database types. And when they're run on each different platform, the back end of the script understands how to do the right thing for each kind of database. So what's this look like? And why would you want to do this? Well, first of all, if your migrations are described as a procedure, then you can identify each one separately, and you can tell which ones have been applied to which databases, when you change them, and some of them can even be rolled back. The same way that you can roll back to an earlier version of your code with version control, many migrations can be written in such a way that they're reversible, and you can specify what the rollback procedure is. You can manage your migrations with version control, right? If you click around in a GUI and do some things to the database, you can't version what you just did, right? You have to just sort of remember it and pray that you'll get it right if you have to do it again in production. So the theme here is, if you can automate something, you can make it much more reliably repeatable. And you've already seen an example of this, assuming that you've been reading and following along and stuff, where instead of installing specific libraries or so-called gems that your app depends on, you put a specification of which ones you depend on in the gem file. And then you run bundle install, which actually creates a specification of here's the actual libraries that are in use right now, which versions and everything, so that when you go to production, it can ensure that the production environment is an exact match for where you developed, right? So this avoids, or helps to avoid, problems of the form, wait, this all worked on my development machine, but when I push it out into the production mode, all of a sudden, I didn't change anything and it doesn't work anymore. So the theme is, don't do it, automate it. Don't dream it, be it. Okay, a few people recognize that. That's good. So you specify what you want to do, and then you create tools to automate the doing. And as with so many other aspects of automation, Rails has some help for you here. So we're going to meet our first code generator. Actually, it's not really our first code generator. You already met one. When you say Rails new and you create a new application, and all that stuff magically appears, that was sort of a trivial version of a code generator. But this one's a little more interesting. I can say Rails generate migration and pick a name for what my migration is going to do. And let's go take a look at what the body of a migration typically looks like. So when I say Rails generate migration, the only part that I actually get is I get an empty def up method and I get an empty def down method. Everything else I got to fill in myself. So what is this migration doing? It's going to create a new table, because this is presumably the very first time I'm trying to run my app. The database doesn't even exist, right? I have to create a table, in this case to hold some movies. And within that table, I'm going to have a title, which is a string, a movie rating, which is a string, a release date, which is a date time. And we'll go through the syntax of these a little bit later. But the important idea here is I'm creating a description of what to do to the database, right? As opposed to opening some GUI SQL tool and poking around and trying to do stuff. How about this? Drop table. Pretty dramatic. It means destroy, incinerate the table forever and without prejudice. But the idea is we're trying whenever possible to make migrations reversible. So the up migration, which means going up from the current version of the database schema to the next version, is about creating a table with some columns. That means logically the down migration, how would you reverse that or undo it, is destroy the table. Right? And obviously, there will be cases when your migration does a destructive change that can't be reversed. But whenever possible, you want to give yourself the ability to backtrack. So And by the way, introducing a new icon, the little gear with the semicolon. I think it's very clever, code generation. So we've just created the migration, right? We have a script in a file, but we haven't actually done anything yet. We haven't applied the migration to the database. To do that, on our development environment, we say rake db migrate. That causes a bunch of automation to happen, which tries to take that script and run it against our development database. And if all goes well and we decide that we're happy with the changes, we have to apply it in production. Now, the specific way you do this depends heavily on the production environment you use. We're using Heroku, which is about the easiest production environment in the universe. So all you do is put the word Heroku in front of most rake tasks, or at least the ones that make sense in production, and they kind of just work. So you'll be doing this process for homework too if you haven't already. Conveniently, when you apply the migration successfully, it has the side effect that it also records in a separate database table maintained by Rails which migrations have been applied. So if I just finish doing all these steps and then I type rake db migrate again, the correct thing will happen, which is nothing will happen, right? It'll look in the migrations table and say, oh, there aren't any migrations in my list of database migrations directory that have not already been applied, therefore nothing to be done. Right? So running migrations is idempotent in the beautiful language of computer science. So this brings us to sort of our first, cookbook method. When you want to augment the functionality of your app, because we're using model view controller, it means you've got to add some subset of models, views, or controller actions. So starting with what we've seen so far, how do you add a new model, or how do you change or add some attributes on an existing model? The first thing you do is you create a migration describing the changes you want to make. So Rails generate migration plus a name will give you some boilerplate, and then you fill in what the changes are. You apply the migration. Hopefully all goes well. You rake db migrate. And if there's a new model being created, well, you also kind of need a file. So as we've seen, models go in the app/model subdirectory, and we'll experiment with doing a little bit of this today. Right? But this is sort of a, as close as there is to a cookbook recipe. If you want to change your app, first thing you need to do is create a migration, apply the migration, and if there's a new model, create the new model. Simple enough. An object representing a database. Unlikely, right? That's just far too general, because if we said t.datetime, how do we know what part of what table in the database that would even refer to? An object representing a model instance. Thumbs down, right? Doesn't make a lot of sense, because we've already kind of seen what models look like. Models certainly have attributes, but we don't have to tell the model what types its attributes are. An object representing a table is correct. Okay? So we're creating a table, we're giving the name of the table, and as we said in the previous segment, when you create a table, you have to decide what the columns are going to be, right? Each row in the table is going to store one model instance, and the columns of the table are going to be the model's attributes. So the database does have to know, right? We need to tell the database something about what type of object each of those attributes is going to be, and that's what's going on in create table. And technically, blue is not wrong, but I was hoping most people would not cop out, and thankfully you didn't.